All right, welcome to chapter 12. I know the school year is quickly coming to an end. Let me first thank all of you for your feedback for the upcoming, that's going to really help me next year for the video lessons. I really appreciated all of your feedback and your honesty. All right, so here we go, chapter 12. There's a couple things we're going to start with in this first part of chapter 12. It's just you being able to classify triangles. All right. Some of it you may remember from previous school years. All right. So the first one is a scalene triangle. There are no congruent sides whatsoever on the scalene triangle. All right. So if you look here, we see that there's no indicators here anywhere. All right. So that's very important. There is no indicators here indicating that any of these sides are the same. All right, so we can say no sides are congruent. I'd like for you not to always try to eyeball a triangle and figure this out, but actually look for the geometric markings. All right, so then we have an isosceles triangle. And here, these two marks here say, hey, these two sides are congruent. Okay, so these two sides are congruent, and there are at least two sides. Then we call that an isosceles triangle. And then these markers here, all right, this is what I want you to begin to look for. It says all three sides are congruent, therefore that is an equilateral triangle. All right. And then we can identify triangles by the angle. All right, by the angle. All right, so most of you have come to recognize, hey, this one right off the bat, this is a 90-degree. So therefore, it is a right triangle. All right. And then you say, look at this and say, hey, all of these have markings that they're congruent. Therefore, it is an equiangular triangle. All right. So we have equilateral triangle and we have equiangular triangle. All right. Three congruent angles. And then the last two I like to look at is the acute. And when I think of an acute triangle, I think, oh, it's so cute. And so when I think in that terms, we always think of little kids like that. So I like to think of an acute triangle that's so cute. Small, cute little kid, cute little puppy. So then we'll say that this one is less than 90 degrees. All right. And then obtuse, obviously it has an angle that is greater than 90 degrees. All right. So those are some basic things you want to know about your angles. All right. And markings you want to be able to, when you classify your triangles by the sides. And that's going to be very important moving forward because the directions won't always tell you that it's an equilateral or isosceles triangle. The markings will just be there. Same with the equiangular or right triangle. Those markings will just be there and you'll be expected to understand that that's what that means. All right. Okay. If you join me on the next page of your student journal, you'll see that it talks about two theorems. All right. The triangle sum theorem, and we know that sum means that we are doing some addition. And then we have the exterior angle theorem. All right. So the triangle sum theorem. All right, sorry about that. Somehow my screen had to go back. All right, so when we talk about the triangle sum theorem, we know that sum means that you're just going to be doing some addition. All right, so sum implies that there's some addition. All right, so it says the sum of the measures of the interior angles of a triangle is 180. All right, so in other words, if I take the measure of angle A plus the measure of angle B plus the measure of angle C, they will equal 180. All right. And then we have the exterior angle theorem, all right, which says the measure of an exterior angle, this is an exterior angle because it falls outside of the triangle, is equal to the sum of the measures of the two non-adjacent interior angles. All right. So angle C, as you can see, is adjacent to angle 1. So the sum of these two angles here all right, are the same as the sum of this angle, all right? And that's going to become very important that you memorize that rule and recognize that, hey, if I want to know what this is, I just need to know what these two are added together. All right. All right, and our third theorem is the corollary to the triangle sum theorem. All right, it says the acute angles, remember acute angles are less than 90 degrees, of a right triangle are complementary. All right, so that means that angle A plus angle B is 90. And if you think about it, it really makes sense, because if this is a 90 degree, if angle C is a 90 degree angle, and a triangle is only 180 degrees, then the sum of these two would have to be 90. All right, real simple, real easy rule to follow. All right, let's move on to some actual working with these different theorems and angles. Okay, so let's talk a little bit about these triangles that you have in your journal. Let's look at the first one, PQR. All right, it appears that it has no congruent sides. Okay. So therefore, if there's no congruent sides, we can conclude that therefore it is a scalene. All right, and we can tell that by size. But what if we talk about its measures? If we look at the measures of the triangle, this angle here appears to be greater than 90. All right, and if you measure it, you'll find out that it is greater than 90 if you measure it with your protractor. So then, therefore, this is an obtuse angle. So then if we were to classify this, we can classify it as a scalene obtuse. All right, let's talk about our next triangle. All right, so one of the things we'll find out is once again, it appears that none of these sides are the same length. So we can call it a scalene. All right, because none of these sides appear to be the same. However, if we measure it with your protractor, you will find that this is a right angle. So we're going to call this a scalene right. All right. In our third example, we actually have two sides that are congruent. All right. So when we have two sides that are congruent, we call that an isosceles. All right, and if we measure each of these angles, we'll find that they're all less than 90. So it's an isosceles acute. All right, so identifying triangles seem to be pretty good, but let's look what happens when we have to draw our own. Just like we were doing in the last chapter, we were doing a lot of drawing. So let me change and get some graph paper, and let's see what happens when we have to draw our own. All right, so here we're asked to classify triangle ABC. All right, so here we're asked to classify triangle ABC. All right, and we're given 6, 6 for coordinate A, so 6. 6 is A. B is 9, 3. And C is 2, 2. And it looks like I've drawn my, right? So there is my triangle. It's not really straight, is it? Makes it kind of hard. Let me see if I can do this with a straight edge. It may make it a little easier for you. Okay, so perhaps this is a little bit better. I tried to make my lines thinner. All right, so they want us to classify it by its sides. Okay, so if I look at each of its sides, and if I just going along in the graph paper, or even if you were to measure it, you will find that they're not the same sides. So right off the bat, I can tell that this is going to be a scalene. All right, because no sides are the same. And if you measure them, you find out none of the sides are the same distance. We did our distance formula. And if we were to do our distance formula, or if you were just estimating just based upon counting the distances between each point here, you would find they're not. So this is scalene. All right. Now, how do I know if it is a right triangle, acute, or an obtuse angle? Okay. Well, if you look very closely here at this angle here, you'll notice that this is a right angle. Let's do it in red. So we notice that this right here is a right angle. All right. So here you have a scalene right angle. Okay. When you go to classify this triangle. All right. And how else might I know that it's scalene right? Well, one of the things I could do just to say, hey, how do you know that? Because we talked about perpendicular lines. Even if I were to extend this out, because if you notice it has a rise of 1 over 1. So let's say if I took these lines and extended them out. All right, and looked at these two lines. This line here has a fall of 1 over 1. This one is a rise of 1 over 1, making them perpendicular. So if they are perpendicular, then therefore I now have a right angle here. All right, because these lines, if I extend them out, are perpendicular to each other. All right, let's move on to talk about some other things there in your lesson for today. All right, hey guys, welcome back to the show. We're now at problem number 5. I don't know how to make this any more entertaining for you than that. All right, so we're talking about measuring an exterior angle. We said earlier that the measure of this angle here is equal to the sum of these two. In other words, so if I have the measure of angle 1 is equal to, and these two happen to be congruent, the measure of 53 plus 53. All right. So therefore, the measure of angle 1 equals, drum roll please, 106. All right. The nice thing is that, well, let's double check it. Okay, well, let's double check it. If we say that the sum of the interior is 180, and we were to subtract both of these from it, or we were to subtract 106, 10 minus 6 is 4, 7. All right, so then we'd say, based upon this, that this is 74. All right, so if that's 74, what is, and we now know that this is entire distance here is a straight angle. Straight angle is 180 minus 74. And 180 minus 74 will also give me 106. Therefore, I must be correct in my measurement. All right. Let's look at it when it looks a little different. All right, so now what happens when we throw in variables? You got to be kidding me, right? Nah, not kidding, but the setup's the same. The setup is the same. We said that if I can take these two angles here, 40 plus 5x plus 15, that they would be equal to this. So it doesn't change. All right. And then once we set up our equation, we just solve it the same way we would any other equation. And I'm going to start by combining like terms. All right. 40 and 15 is 55 plus 5x equals 8x minus 5. All right. Subtract 5x from both sides. Bring down my 55. 8 minus 5 is 3x minus 5. All right. Add 5 to both sides. I have 60 equals 3x. Divide everything by 3. And I get 20 equals x, or x equals 20. All right. Well, let's see if this is true. If it's true and if I've solved it correctly, then let's plug that in. All right. So we have 40 plus 5 times 20 plus 15 will equal 8 times 20 minus 5. All right, so let's see if we get a true answer. 40, 5 times 20 is 100, plus 15. 8 times 20 is 160, minus 5. This will equal 155. All right. And here, let's do it the long way. Let's do 140 plus 15. Let's combine these two. 155 equals 155. All right. So not only did I find x, but I actually plugged it back in to see if I add these two angles together. All right. If I add these two angles together here, will they equal this angle, which we plugged in here? All right. Okay, so this is our final example, and it is one of those beautiful word problems that you all love, and I know you're just so excited right now to be able to do this. All right, so let's break it down so you can learn how to set it up. All right, in a right triangle. All right, so we know we're talking about a right triangle. I'm just going to draw one here. Maybe I'm going to draw one here. Let's try again. All right, so in a right triangle, the measure of one acute angle. So we know that one angle is, all right, so let's talk about our things. We say is or equal to twice the sum of, so this goes all the way back to our verbal expression when we say the sum of. All right, so that means that I'm going to put something in parentheses because I have a of statement. The sum of the measure of the other acute angle, we don't know what it is, so we'll call it x, and meaning plus 30. All right. Find the measure of each acute angle. All right, so if we say this one is x, then we said that this one was 2 times the sum of the other measure and 30. All right. So now let's set this up. All right. We know that all triangles equal 180 degrees. All right. And I'm going to plug in our formula that we just wrote for this angle. 2 times the measure of x plus 30 plus our other angle. And I'm also going to include our 90-degree angle, which they've already given us. All right, because they've already let us know that this right here is 90 degrees. All right, So we back to just a regular equation. We're going to start with distribution. 2x plus 60 plus x plus 90. All right, now I can combine like terms. I'm going to start by combining both of my variable terms, and I get 3x plus 60 plus 90. And now I can combine my constants, and I get 3x plus 150. All right, and at this point, I'm going to go ahead and bring everything else down. I'm going to bring down my equal sign, and I'm going to bring down my 180. All right, let's subtract 150 from each side. And this is 30 equals 3x. This cancel out. Divide both sides by 3. And x equals 10. So now that I have 10, I'm going to draw my triangle just a little bit larger here. All right, we already established that this is a 90 degree. We said x was 10, so therefore this angle is 10 degrees. All right, now just by looking at it, if the sum of a triangle is 190 and this right here is 100, I should plug in my value for x and this should equal 80. Let's see if it does. All right. So if I have 2 and x was 10 plus 30, I can combine like terms and I get 2 times 40 and I get 80. So therefore, this measure here is actually going to be at 80 degree. All right, and there you have it. All right, enjoy the rest of your day and your work, and if you have any other questions, I'll be glad to answer them on Monday or text me.